Hey guys! Hopefully you are enjoying a sort of snow day today. I'm actually making it's Wednesday afternoon and I'm making this video, so who knows if it's actually gonna snow or not. But if it does and you get to have a sort of snow day tomorrow, enjoy. Hopefully you get to play a little bit outside, but after you do your work. So yesterday was rational numbers, right? And we talked about how rational numbers are numbers that you can write as a fraction. So I was having you write different numbers as fractions. And today is multiplying rational numbers, which is basically just multiplying fractions. So you would have done this before. And so you hopefully remember that when you multiply fractions, you simply multiply the numerators and multiply the denominators. Right? So it can be as simple as what you see in 1a. 1 times 4 is 4, and 2 times 10 is 20. Right? So 4 over 20. And then, of course, you do need to simplify, so that one would be 1/5. I don't know for sure if your 5th grade teachers talked about simplifying before you multiply, but it is an option. And so I want to show you what that looks like in case you want to try that. So 1b is a perfect example of a question that would be good for this. So I can multiply them just like I did 1a, and I can do the, numerator times numerator, which would be 5 times 6 is 30. And then I can do 12 times 10 is 120, right? And then, of course, I would simplify that, which would be 1/4. But when you have larger fractions, or at least ones with like actually smaller fractions, bigger denominators, you can try to simplify them before. And you do this with the diagonals. So when I'm looking at 1b, 5/12 times 6/10, if I take note of the diagonals, 12 and 6, I can simplify those right now before I multiply. And since they both divide by 6, I can do that now, and I would get 1 and 2. Right? And then I could go ahead and multiply now if I wanted to. 5 times 1 would be 5. 2 times 10 would be 20, right? Which is also going to simplify to 1/4. We know that. I could keep going, though, with 1b. And not only can I simplify 6 and 12, but I could also do that with 5 and 10. And I could divide these both by 5. And I would get 1 and 2. Right? So now I'm really just doing 1/2 times 1/2, which equals 1/4. Right? And we knew that because we got it both of the other ways. So you can simplify after. You can try to simplify before. Either way, you have to simplify, but it'll be your choice whether you do it before or after. So let's take a look at a few more examples like that. Number 2a. Right? So you don't have to do this. You could get 27 over 48 and simplify that. But I recognize that 3 and 12 both divide by 3. So I'm going to do that now. 3 divided by 3 is 1. I can get my pen. There we go. And 4 divided by 3 is 4. So now I just have to do 1 times 9 and 4 times 4, which is 16. Right? So usually if you simplify before, you won't have to simplify again after. Sometimes it works out that you might have to do it once more, but usually if you take care of it before, you won't have to do it again. And you can't do this with all fractions. These ones I can, but if you were doing like, 1/2 times 4, well, not 4, that would simplify. I'll make that a different number. 1/2 times, 5/7 or something. Like there is no way to simplify that before. So this doesn't work for all fractions. But it is really nice, especially when you have big ones. And you'll see when we do mixed numbers, this is a time when you actually will really do that. So 2b, maybe I wouldn't. Maybe I would just do 6 times 3 is 18, 9 times 11 is 99, 18 over 99. Or, I could simplify the 3 and the 9 now. There's also a negative in that one, but that shouldn't really matter. It's just going to make your answer be negative. So I want to move on to mixed numbers. When you multiply mixed numbers, this didn't say this at the top, but I typed it in here. You have to convert them to improper fractions before multiplying. And I noticed that multiplying has a typo. Just ignore that. So convert them to improper fractions before multiplying. You will not get the same answer if you don't do that. Sometimes kids think, well, I'll just multiply the whole numbers, multiply the fractions, and it'll work out the same. And it doesn't. I've tried. It doesn't. So you do have to convert these to improper, right? So 3 3/8 would be 24, 25, 26, 27 over 8. And 2/3 would be 7 over 3. And it's often mixed numbers when you do the simplifying before, because, you know, the mixed numbers tend to be bigger fractions, like 27 times 7, ugh, you know. But I could divide 27 and 3 by 3 right now and turn that into a 9 instead and turn this into a 1. Now that's a little easier to simplify. Or, well, multiply also. 9 times 7 is 63 over 8, right? And that's a little bit better than having 189 over 24. So you would need to convert that back to a mixed number from there. So 8 would go into 63 7 times, with, what, 7/8 left over. So you will have to make sure you convert them back. So again, 3b, this would be, what, 11 over 6 times 33 over 8. Okay, so the only thing I could do there would be to divide the 33 and the 6 by 3, and that's helpful. Then I get it down to 2 and 11, right? So then I would have 121 over 16. So it's up to you. Sorry, that pen looks terrible. You don't have to simplify before, right? You can definitely stick with just multiplying the numerators, multiplying the denominators, but it is nice to have the option. So then, of course, I was going to do a couple more practice, but I think I'll just have you take care of that today. Just a couple things to note here. If you multiply two negatives, it's going to be positive, right? So that would happen on 8 and 11. And then you're also going to have to do this with algebraic fractions. So I'm going to talk about that real quick. Okay, so multiplying algebraic fractions is really going to be pretty similar to multiplying numeric fractions. So again, you're going to multiply the numerators. So 2a times b squared is just what it sounds like, 2ab squared, right? Over top of bd. But you have to simplify it. So you can do just like before. You can just multiply them and then simplify after, which is what I'm doing right now. So I've multiplied them, and now I see that one of these d's on the bottom will cancel out one of these d's on the top. Or I'm sorry, I crossed off the wrong thing. That was supposed to be a b canceling out one of the b's. So that leaves me with 2ab over d. In the example that they show you, they actually simplified before they multiplied. And again, that's using the diagonals. So I can compare right here, right? This 1b will cancel out one of these b's. So I'm really just left with a b here. 2 times, then I have 2a times b would be 2ab, and then just a d on the bottom. So again, you can simplify before or after, and I'll show you an example, I guess, of doing it both ways, and then once you practice today, you can decide, and you can go back and forth. Like sometimes I'll simplify it before, like if it's really big numbers, and then other times if they're, you know, manageable numbers, I won't do it. So it's just nice to have the option. So let me look at 5a. In order to simplify it before, I'm looking at the diagonals. And the only thing I see that I could do to simplify would be to take this x here with the 2 and have that cancel out one of these x's. So now this is really just x. So x times z would be x, z on top. And then 3y times 2 would be 6y. Okay, and then for 5b, I'm not going to simplify before, although I do see that I could do that with the r's. So I'm just going to multiply it as it is. 7r s squared over r squared 10, right? And then I'll just simplify this now. This r will take care of one of these r's. So I'd be left with 7s squared over r10. I guess I'd probably rewrite that as 10r just because it's a little bit better that way. So there you go. You can simplify before or you can simplify after. And there was a couple more examples there. I won't do all these for you, but I do want to look at 16. I feel like that's probably a good one to end with. So this one, I'm going to write it a little bigger. We have 4t over 9r times 18r over t squared. This would be one that I would try to simplify, right? Because I see the 9 and the 18, and I can divide those both by 9. So this becomes 1, and this becomes 2. And then the r's actually cancel each other out. Then I also can take this 1t here and have that cancel out a t here. This just gets a little messy, right? So I'm left with a t. So now I have to kind of pick through what I had left over. And I have 4 times 2, right? If you can see that 2 there. So that would be 8. The pen is not very sensitive. And then 1 times t. So 8 over t is how that whole entire thing would simplify. So the practice today, I made an assessment versus a OneDrive. So I did put some directions about how to enter the answers, like enter a fraction, obviously with a slash, use lowercase letters to represent a variable. So I thought this one would be okay because I don't think there was any exponents that you needed to add. So just to give you a break from having to do work on the OneDrive. So let me know if you have questions. I plan to go over this with each of the groups when I see you next time in person. So good luck. Let me know if you have questions and have fun in the snow. Bye.